Okay, class, today we are in section 11.1, parallel lines cut by transversals. 11.1, parallel lines cut by transversals. Please add this to your notes. This should be your heading. This should be your heading for your notes. 11.1, parallel lines cut by a transversal. Okay, write down the term key objectives. Write down the term key objectives and add the objective to your notes. Learn to identify parallel, perpendicular, and skewed lines and angles formed by a transversal. Learn to identify parallel, perpendicular, and skewed lines and angles formed by a transversal. Once again, get this in your notes.
You know, the great thing about looking at geometric figures is that there's so many really cool angle relationships when you look at some of these things. I want to share some with you right now. Take a look at this picture. So here we're told that line N and line P are parallel lines. And this line here, notice, passes through both of them, crosses through both of them, and that's called a transversal. When we have two parallel lines and a line that crosses them both, it's called a transversal, and you'll notice it forms tons of angles, which is great because, I'm a big fan of angles. You should be a fan of angles. And so there's all these angles. And I'm told that the measure of this angle right here, this very special angle, is 40 degrees. And so the meta question I want us to ask is, what can we say about the other angles? Well, we can actually find the measures of lots of these angles by using various properties that I want to share with you right now. So the first angle I want us to take a look at is angle 2. And I want to see if we can find the measure of angle 2. Well, we can let sort of like the other pieces fade into the background, and notice that what I have here is one line and another line, and they cross. They cross at this point, and these two angles are sort of opposite of each other. They're actually called vertical angles. And there's a really cool theorem that tells us that vertical angles have the exact same measure. And you can actually see this for yourself in general. Notice that here I have two lines, and watch that angle right there. The measure certainly looks like it has the same measure as here. Watch what happens when I change this one. Watch what happens to this one. It's like a magic trick. They both change the exact same way. Vertical angles are congruent. It's so cool. So, in this context, since I know that this has a measure of 40 degrees, that tells me automatically that angle 2 has a measure of 40 degrees because these two angles are vertical angles. Awesome. Okay, now let's move to angle 4. So angle 4 is way over here. Now that seems to have nothing to do with sort of what's going on over here, but now we have to remember the fact that we were told that line N and line P are parallel. And this line is a transversal, and there's a really cool fact, a really cool theorem that I want to share with you. Because notice that if we think about this line and this line sort of parallel, then this angle sort of corresponds with this angle. These are called corresponding angles. When you have two parallel lines and a transversal that cuts them, then in fact these angles that sort of correspond are called corresponding angles. And guess what? Just by looking at the picture, you might guess corresponding angles have the same measures. So in fact, since this is 40 degrees, this angle here is also 40 degrees because they're corresponding angles. This is so cool. Now, the last one I want us to take a look at together is angle 1, way up here, angle 1. How are we going to find that? Well, this is a little bit tricky. First of all, I think it's clear it's not 40 degrees because it looks like a very large angle. But you'll notice that we have this line N, and we have this line cutting through it, and we have this angle here is 40, and the rest of it sort of makes up the rest of the line. So we start here, go 40 degrees, and then go some mysterious number of degrees to get back to that line N. Well, we know that the angle of a straight angle is 180 degrees. And so what I see is angle 1 and this 40-degree angle actually are supplementary angles. Supplementary angles. That means that their measures add up to 180 degrees. Well, this is great, because if I want to find the measure of angle 1, I know that if I add that to 40 degrees, that's going to equal 180 degrees because these two angles are supplementary angles. So what do I do now? Well, we know what to do. All we've got to do is subtract 40 degrees from both sides. We solve this equation. And I see that the measure of angle 1 equals 140 degrees, which is sort of sounds right because it's a really big angle. You see how big it is? So this angle right here, big angle, is actually 140 degrees. And you can see if you add them up, they equal 180, and that's actually completely, completely straight angle. And so we see supplementary angles. And in fact, now, just using these same principles, we can now record all the measures of all the angles. What about angle 3? Well, it's vertical angles with angle 1, so therefore this must be 140. And angle 6 is vertical angle with 4. 4 and 6 are vertical angles, and so therefore this is 40 degrees. These two angles, 1 and 7, are corresponding angles, so this is 140, and therefore this is 140 vertical angles. So now, just knowing one angle measure, and the fact that these are parallel lines crossed by a transversal, we know all the angles. It's sort of fun to know all the angles. I'll see you soon.
Okay, let's get the definition for vertical angles in our notes. The definition for vertical angles in our notes. Just write down the term vertical angles. Draw these two lines here, just like so. Draw those two lines. We don't need the verbiage here. Just draw those two lines. And then you will see that angle 1 is equal to angle 3, and angle 2 is equal to angle 4. These are called vertical angles. Vertical here and vertical there. Vertical angles are equal to each other. So once again, vertical angles, draw the diagram, label 1 and 3, and you know that 1 and 3 are equal to each other, and angle 2 and 4 are equal to each other. Okay, let's take a look at the rest of the diagram. We're going to repeat what he's doing. So once again, this is about your second or third time hearing this. So by now, you should have it down and should be committed to memory. Now, the first thing you need to know is you have two parallel lines, 1 and 2. Here you have a line that is bisecting or cutting the two parallel lines. This line is called a transversal. This is called a transversal. Now remember, all straight lines are 180 degrees. So it's 180 degrees here, 180 degrees there, and 180 degrees there. So here we have an angle of 40 degrees. So since I know this is 40 degrees, and I know this sits on a straight line, then I know that this angle here has to be 180 minus 40, because 40 plus 140 would give me 180 degrees. And notice if I went this way, it would be the same thing. If this angle right here is 140, this right here is a straight line, so 140 plus 40 would give me 180. No matter where I go on this particular diagram, that will happen. Okay, the next thing we should be aware of is that angle 1 and angle 7, they are equal to each other. These are called corresponding angles. Angle 1 and angle 7 are equal to each other. Just like the angle of 40 degrees and angle 4, they're equal to each other. Also called corresponding angles. Corresponding. Angle 1 and 3 are vertical. They're equal to each other. 40 degrees and 2 degrees are vertical. They're equal to each other. 7 and 5, they're vertical. They're equal to each other. 4 and 6, vertical. They're equal to each other. 40 degrees and 6 degrees, corresponding. They're equal to each other. And don't forget, corresponding angles are always on the same side. Always on the same side. Now, when you look at angle 1 and angle 5, they're called alternate exterior angles. Alternate exterior angles. Angle 4 and angle 6, they're called alternate interior angles. Alternate interior. Excuse me, no, they're still called alternate exterior. Alternate interior would be right here. angle 2 and 4, and angle 3 and 7. But the main ones you need to know are vertical here, vertical here, vertical here, vertical here, corresponding here, corresponding here, corresponding here, and corresponding here. Now this is all you need to do your today's lesson. All right, let's get started.